Publish 17th lecture from this channel. This is about test for vector group of three-phase transformers or phase displacement between high voltage and low voltage windings. The case study reference is Synergy Power Mech Transformer serial number 5499 200 kVA. While working with single phase transformers, be it two winding or three winding, primary, secondary, and this is tertiary. When energized, there is no problem of polarity. If this is positive, this will be positive, this will be positive. This is single phase transformer. But when it comes to three phase transformers, there is a phase shift from 0 to minus 330 in three phase transformers. There is phase shift of 0 to minus 330 degree between primary and secondary phases. So, before proceeding in the video, let me ask an important interview question. How does power factor affect this vector group? Or due to various vector group, how power factor is affected? I shall reply this later. Or this phase shift is represented in a 12-hour clock. This 0 to 330 minus 330 degree shift is at the steps of 30 degree. At the steps of 30 degree. So, in a 12-hour clock, this is 12, this is 6, this is 3, this is 9. High voltage vector is taken as reference and it is our hand. It is set at 12 o'clock. And low voltage vector is made to rotate for various vector groups. So the vector for high voltage winding is taken as reference and displacement vectors of other windings from reference vector with anti-clockwise rotation is represented by use of 12-hour clock. Why anti-clockwise positive? Anti-clockwise positive has been recognized as international standard by IE, International Electrical and Electronic Engineers Association. Now IS20, this is minute hand and this is 11, 10, 8, 7, 5, 4, 3, 1, 2, and our hand is made to rotate to explain. IS 2026 Part 1.5 describes that as many as 26 sets of connections in star star, star delta, and delta zigzag, or star zigzag, or delta zigzag. Actually, these 26 sets of connections are hardly required. Most commonly used connection in primary distribution system of India is with clockwise distribution of minus 330 degree. Most commonly used connection in primary distribution (11 kV or 33 kV distribution or primary distribution). 440 volt or 230 volt distribution is secondary distribution. So in India, most commonly used connection in primary distribution is minus 330 degree, lagging, or 30 degree leading. Symbol for high voltage winding comes first, followed by diminishing sequence of voltage. For example, a 132 by 33 by 33 kV transformer connected in star star delta star star delta, tertiary is delta, primary is star, secondary is star, will be represented as with reference of high voltage 0. Means how will you represent it? Y Y 0. First, primary to secondary, high voltage with capital Y, low voltage with small y, phase difference between them 0, and then Y D YD 11 or YD 5 as the case may be. Okay, so 132 by 33 by 33 kV in transformers First, with primary reference, I have already rather high voltage side is reference. So first, primary to secondary, y by 0, yd0. You might have noticed in nameplate vector group of three winding transformer like this. So these digits 0, 1, 11 etc. indicates phase displacement between HV and LV windings using a 12-hour clock for rotation or notation. The phasor representing HV winding is taken as reference and set at 12 o'clock. Phase rotation is always anti-clockwise, being international standard. So our hand indicator will be used as indicating phase displacement angle. This is our smaller hand. This is reference. This will be used for phase displacement angle. 12 hour of clock and 36 degree of circle. It is 12 hour. Why 12 hours? There are 24 hours clock also. Although seldom used. Why 12 hours? Because this whole circle is 360 degree and displacement is between 0 to 30 degree in the multiple of 30. So 360 divided by 30 is equal to 12. So our watch clock or wall clock suits this. Now, so thus 1 is 30 degree, 2 is, indication 2 is 60 degree, and so on. Indication 11 is 330 degree. Now, digit 0 is 0 degree. LV phasor is in phase with HV. Suppose this is a three-phase transformer. A1, A2, B1, B2, C1, C2. A1 in star mode, A1, B1, C1 is sorted. In secondary also, A1, A2, B1, B2, C1, C2. This is sorted. This is star. So phase displacement is 0 degree. Digit 0 LV phasor is in phase with HV. So what is the phasor here? Y 0. A1, A2, A1, B2, C2 sorted. A1, B2, A1, B1, C1 sorted. A1, B1, C1 sorted. Now reverse is in case reverse is the case. A1, A2, B1, B2, C1, C2. A1, A2, B1, A1, A2, B1, B2, C1, C2. Supposing reverse is the case. instead of A1, B1, C1, here A2, B2 and C2 are sorted. A2, B2, C2 are sorted. So what will be the case here? This will be 180 degree displacement in phase. So this will be Y6. So digit 1 is 30 degree lagging. HV lags LV by 30 degree because rotation is anti-clockwise. Digit 0 in 0 degree rotation. Digit 1, 33 30 degree lagging. Digit 11, see digit 1 here, 12 to digit 1 in this direction since it is in clockwise, and 12 and 1 it will be 30 degree lagging, and digit 11 is minus 311 here. This is 360, this is 330, minus 330 degree lagging means 30 degree leading. So when we say DY N11, it means high voltage is connected in delta, low voltage is connected in star, neutral is brought out, and 11 means third LV leads HB by 30 degree. So here I reply my query as at the beginning of the video. What will be the effect of power factor on primary and secondary phasor? There will be no effect. This is an important interview question. Why no effect? Because voltage and current both shift simultaneously, and power factor is the phase angle between voltage and current, cosine of the phase angle between voltage and current. So two-winding three-phase transformers can be divided into mainly 4 categories. Two-winding transformers can be divided into 4 categories. Group o'clock terminal connection. Group 1 is 0 o'clock. Terminal connection delta delta star star. Group 2 is 6 o'clock 180 degree, delta delta, delta star, sorry, star star. Group 3 is 1 o'clock, this is minus 30 degree, it is star delta, delta star. Group 3 is 1 o'clock, sorry, this now group 4. Group 4 is 11 o'clock, star delta, delta star. Now coming to this delta connection mode. Here are 3 windings connected in delta. R, Y, connection terminals R, Y, B. R1, R2, Y1, Y2, B1, B2. And here also this is connected in delta mode. R1, R2, Y1, Y2, B1, B2. But you can see here R2 is connected to B2. And in this mode, R2 is connected to Y1. Here Y2 is connected to R1. Here Y2 is connected to B1. So they are entirely different mode. We have already discussed that in India, primary distribution is mainly DYN11 based. Vector group of transformer is important to be known when 2 transformers are running in parallel. So what will happen if the vector groups are not same? The peak voltages will reach at different times if operated in parallel, and that may result in dead short and transformer may get damaged. 2 more configurations of delta is possible. If output terminal is taken instead of R2, R1 is taken output terminal, Y1 is taken output terminal, and this B1 is taken output terminal. This will be another configuration for delta. Here also, if instead of R2, Y2, Y2, output terminals are taken as R1, Y1, B1, this will be another configuration. So how should we get to know if it is DY11 or DY5? Here capital R is indicated for high voltage, capital RYB for high voltage, and small RYB for star connected low voltage. Let us to draw a vector diagram of this star, and here R, Y, B in clockwise fashion, delta R, Y, B, and star delta does not have a neutral, but let us have a virtual neutral by virtue of this line. Suppose here is Newton virtual neutral. So R1, Y1, B1 are common point neutral points. This is neutral point. We draw phasor R parallel to this, phasor Y parallel to this, and phasor B parallel to this line. What we do to check if it is dy11 or not? R, Y, B high voltage, R, Y, B low voltage. What we do? These are sorted. High voltage R phase and low voltage R phase are sorted. For that matter, any two phase can be sorted. And a 415 volt supply is given. How this vector diagram change with these two sorted? R and R is common. High voltage and low voltage red phase is common. Both comes at this point. Here is Y phase of low voltage winding, and this is B phase of C. This has been shifted here. This neutral has been shifted here. This R has been shifted here, and we are left with Y phase like this and B phase like this. So what is the condition for dy11 or dy11? R and R is sorted. Voltage between blue phase of high winding and yellow phase of low winding should be greater than BB. See, BY should be greater than B. See, this is BY. Capital B, small y. This is greater than BB. Means voltage between B and Y should be more than voltage between B and B. Voltage between this and this terminal should be more than voltage between this and this. And YY means this voltage BY should be greater than BB. Okay, BY should be greater than BB. Means voltage between B phase of HV terminal and Y phase of HV terminal should be greater than voltage between B phases of HV and LV phases. And voltages between Y phases of HV and LV phases should be equal to voltage between Y and B. मतलब capital Y and B. What was the measured value in the instant transformer? YY was 390 volt. Capital Y, small y, voltage between Y phase of higher voltage and Y phase of lower voltage was 390. Voltage between Y phase of higher winding and B phase of lower winding, low voltage winding was 390 degree. Voltage between blue phase of higher winding and yellow phase of low voltage winding is 404. And voltage between blue phases of high and low voltage winding is 380 volt. So conditions are satisfied. By voltage between B phase of higher voltage winding and Y phase of LV winding is greater than voltage between blue phase of high voltage winding and blue phase of low voltage winding. And voltage between Y phase of HV winding and Y phase of LV winding is equal to voltage between Y phase of HV winding and B phase of LV winding. So I repeat once again, this is high voltage winding, capital R, capital Y, capital V. This is low voltage winding, small r, small y, small b. High voltage R phases of the both winding are shorted, and 415 volt supply is given through high voltage side, not low voltage side. Okay, and condition is By voltage. By voltage should be more than Bb. Capital B, small y voltage should be greater than capital B, small b. And capital Y, small y voltage should be equal to capital Y, small b. In this data we see it is satisfied. So this is division 11. Thank you. Happy learning. Stay safe.